So differentiability is going to be a lot like looking at continuity. Okay, so we looked at continuity a lot on how to prove that something was continuous, right? We did our limit had to exist, our f of x at that point had to exist, and then they had to equal each other, right? We did a lot of that. You guys are pretty good with that. Usually on the questions that I have given you asking about continuity, you've done pretty well with those. So differentiability is similar, but of course different at the same time. So differentiability, we can talk about differentiability at a point and over an interval. So differentiability at a point a function is differentiable at x when its derivative exists at x. Okay, now that sort of sounds like a sort of redundant definition, right? It should be implied that that's the case. But we'll talk more about what we need to do to test for that. Okay, and then you can also have differentiability over an interval. And this is when a function is differentiable on an open interval whenever it is differentiable at every point in the interval. So much like continuity, we had a test for finding if something was continuous at a point, right? If we needed to know if something was continuous over an interval, we basically just looked for all the discontinuities, and then if they were in that interval, then our answer was no, right? It was not continuous for those points. So it's going to be similar here. We need to check for places that a function might be not differentiable, and then if it's in whatever interval we're looking at, then that would mean it's not differentiable on that interval. Okay? This is very, very, very important. A function must be continuous in order to be differentiable. So if a function is not continuous, if you have a jump, a hole, or an asymptote, then it's definitely not going to be differentiable, right? So a function has to be continuous in order to be differentiable. So let's look at what we're going to do with this. Let's consider this function f of x equals the absolute value of x plus 3. Okay? So we are supposed to find f prime of negative 5. F prime is our derivative. What does our derivative tell us about a graph? Slope of the tangent line, or in this particular case, since they are straight lines already, just the slope of the line, right? So if we look at this graph, what is the slope of the tangent, or the slope of the actual line in this case, at negative 5? Negative 1. Okay? Then they ask us to find f prime of 0. So the slope of the line where x equals 0. So Wesley, what's my slope of the line there at x equals 0? Positive 1. Very good. Okay, and then they ask us the tricky question. They ask us to find f prime of negative 3. That falls right here. What is the slope of the line at that point? Okay? On the left-hand side, we have negative 1, right? On the right-hand side, we have positive 1. But right there at that point, I'm not really sure what I should say is the answer. Because there's not a slope of a line right there. So this is an example of a function that is not differentiable. Okay? Because you have a clear derivative on the left, you have a clear derivative on the right from both sides, but they don't equal each other. Right? So I meant to look this up and I forgot. I can't remember if this does not, I think it does not exist. it is possible that it might be undefined instead. I think it does not exist. I need to look that up. It won't be terribly important for you there. So, functions are not differentiable at sharp turns in the graph. A place where you've got a derivative on one side and then a different derivative on the other side. A word that we sometimes use for those sharp turns is a cusp. C-U-S-P. Cusps. It's kind of a weird word. Last year, for some reason, I think that class really liked that word. And they would use it often in an almost joking sort of way. Cusps. So, you don't have to use the word cusp. It is fine to just call something a sharp turn. If you use the phrase sharp turn on the AP exam in the response section, they will give you credit for that. So you don't have to have this word. But in case you see this word, it's possible it might show up in a multiple choice or something like that. Alright, so in order for a function to be differentiable at a point, x equals a, first of all, f of x must be continuous. At x equals a. Right, so it's got to be continuous at that point. And then our derivative from the left-hand side and the right-hand side have to be equal to each other. So, the only real way that we can do a derivative from the left and the derivative from the right is to use limit notation, right? Because with limits, we can do a limit from the left and a limit from the right. With derivatives, we can't necessarily do that, although we can sort of use our shortcut to check it, or if it's a multiple choice question, we could use our shortcut to help us do it more quickly, right? But if it's a free response, we're going to have to write it out. So we're going to have, I'm going to write this down, derivative from left equals the derivative from the right. That's just to keep straight what we're talking about. The notation you're going to have to use is the limit as x approaches a from the left of f of x minus f of a over x minus a equals the limit as x approaches a from the right of f of x minus f of a over x minus a. Okay, so a function is not differentiable if you have a point of discontinuity, if you have a sharp turn in the graph, or it's also not going to be differentiable if you have a vertical tangent. What is the slope of a vertical line? It's not a number, it's a word. What's the slope of a vertical line? Undefined, right? So since the slope would be undefined, it means the derivative would be undefined at that point, so it can't be differentiable. So let's look at some problems. All right, so we want to know if the function f of x is differentiable for all values of x. So for this problem, I've got x plus 1. That is just a line, right? lines are continuous and differentiable everywhere. I've got this problem, x plus 1 squared. That's just a quadratic. Quadratics are continuous and differentiable everywhere. So I'm not going to have a problem with this continuity with either one of these, except possibly at the point where they meet, right? That's my only issue. And typically with piecewise functions, that's going to be the issue that you run into. So I need to check for differentiability at x equals 0. Okay? So before I can check for differentiability, what do I have to check for? Continuity. Because if it's not continuous, the answer to this is no, and I move on, right? So I need to check for continuity. So to check for continuity, I would have to do the limit as x approaches 0 from the left of f of x. And from the left, which function are we using? Top one, right? So that would be the limit as x approaches 0 from the left of x plus 1, which would be 0 plus 1, which would give us 1. Just a little notation help here. We want this to be continuous, right, so that it'll be differentiable. But do we know that it's continuous? Does it tell us that it is continuous? It is not. So you need to do your limit from the left and the limit from the right separately. Don't set those equal to each other, because it didn't tell you it's for sure continuous, and if it ends up not being continuous, your work doesn't really look right. You only want to set the limit from the left equal to the limit from the right if it tells you that it is continuous. So, limit as x approaches 0 from the right of f of x. This is the limit as x approaches 0 from the right. Which function is on the right side? Bottom one. That is going to be 0 plus 1 squared. Also gives us 1. Okay? So what other piece do I need? I need f of 0. And which function do I use for f of 0? Top 0 plus 1 is 1. So since limit as x approaches 0 from the left of f of x equals limit as x approaches 0 from the right of f of x, and that equals f of 0, we would say f is continuous at x equals 0. A lot of times if you see this on free response, they'd probably ask you to prove continuity in part A, and then they'd ask you about differentiability in part B. So you're looking at sort of like two parts of the FRQ here. So we have shown it's continuous. So that means it could be differentiable, right? So we've got the derivative from the left, right? And the only way we can show this derivative from the left is to use limit definition. I mean, we can kind of shortcut it. We might can get by on some multiple choice with it, but for free response, we got to do limit definition. So we're going to do the limit as x approaches 0 from the left, and I'm going to write the rule out just so we remember it. F of x minus f of a over x minus a. Actually, I guess I should do an a right there. That's my rule, right? So for this one, that is going to be the limit as x approaches 0 from the left of f of x minus f of 0 over x minus 0. So f of x, when we're approaching from the left, we're using x plus 1, right? So we would have x plus 1. That's my f of x part. All right, so f of x is, gracious me, x plus 1. Then we have to do minus f of 0. We already found f of 0, right? It was negative, or it was 1. So f of 0 is 1. And then that's all over x. Right there. So the positive 1, negative 1 are going to cancel. We got limit as x approaches 0 of x over x. And what does that reduce to? What is x divided by x? 1. And what is the limit as x approaches 0 of 1? It is also 1. Okay, so from the left, our derivative is 1. From the right, we're going to have to do the same process, but we're going to use the second function. So our derivative from the right. So limit as x approaches 0 from the right is going to be f of x minus f of 0 over x minus 0. This time we are using the second function, x plus 1 squared. So we've got x plus 1 squared minus 1 over just the x, because x minus 0 just gives us x. Okay, what should we do now? Can I factor out an x just yet? I got that square. What can I do with it? We're distributing there, so we got limit as x approaches 0 squared. You got a square, double square here, so x squared plus 2x plus 1 minus 1 over x. And that plus 1 minus 1 is going to cancel for me. Now I can factor out an x, so I'm going to have the limit as x approaches 0 from the right of x times x plus 2 over x. Those x's right there can cancel. And then what do I do from there? Plug in 0, so I get 0 plus 2, which is 2. So my derivative from the left, did it equal my derivative from the right? It did not. So we would say, therefore, f of x is not differentiable. At x equals 0. Let's just get a picture in our heads of what this looks like. Let's graph this on Desmos. Alright, so if I graph this, y equals x plus 1 for x is greater than or equal to 0. I'm sorry, less than or equal to 0. And y equals x plus 1 squared for x is greater than 0. Alright, so if you look at the picture here, you can see these are connected. It's continuous at that point. And it really looks almost smooth, right? It almost looks like a smooth curve. But the more you zoom in here, the more you can see that it looks like, you know, two lines that are not making a straight line, right? So, whenever we zoom in to one that is differentiable, it should look smooth. If you zoom really close in, it should just look like a straight line at that point. But here, you can see the more you zoom in, you can tell these do not have the same slope from both sides. So the sharp turn doesn't have to be like, you know, it doesn't have to be what we consider a sharp turn like driving, you know, like where you're really cutting back. But it basically is just where, like, when you zoom in, it doesn't look smooth there. And the closer, see, our derivatives weren't terribly far off. We had 1 and 2. So the closer they are to each other, the more they will look the same. So that makes a difference. Like if I put let's see if I can make this look different. Yeah, like if I put a 9 right here, still continuous, but the turn looks a lot sharper, right? So sometimes it will look very sharp like this, and like when you're zoomed out, you can tell, oh yeah, that is not going to be differentiable. Sometimes it may almost look differentiable, so you have to look at it more closely. Okay, questions? Okay, so let's look at a problem. It says, let f be the function defined above. Which of the following statements is true? So, all of our options say f is not differentiable. So I'm feeling confident f is not differentiable. Okay? So, what I need to know is why is it not differentiable? So, what's the first thing we always have to check for differentiability? If it's continuous. So, because this is multiple choice, like technically I should be doing limit as x approaches 5, because 5 is going to be our issue, right? You can see 5 is the point that we're looking at here. Of f of x from the left, right? I should be, if this was for response, I'd have to write that out. But whenever I do that, I would just be plugging 5 into that top equation, and I would just get 2. All right. Since it's multiple choice, you don't necessarily have to write that. You can just think about plugging it in. And then your limit as x approaches 5 from the right of f of x, you're plugging 5 into the second equation, right? So you have 2 times 5 minus 4, which is 10, minus 4, which is 6. So, we really don't have to go any further here, right? Is our function continuous at x equals 5? No. So, that is the reason that it's not differentiable. So, any of this other stuff does not matter. Sharp corners, vertical tangents, not defined, that doesn't matter because we're not continuous at that point. We've got to jump in the graph. So A would be our answer. Okay, questions there? All right. Let's look at this next one. Which of the following statements, if true, cannot be used to conclude that f of 0 exists? Alright, so anybody see when they want to rule out? It can, because this is saying if true, cannot be used to conclude that f of 0 exists. So if we can use this to conclude that f of 0 exists, then we want to, that is not the correct answer choice. So anybody see one that does tell us that f of 0 exists? B, right? If it's continuous, that tells us the limit has to exist, and f of 0 has to exist. So we know if it's continuous that f of 0 has to exist. Okay? C, because for it to be differentiable, what has to be true? It has to be continuous, right? So if C is true, that means B was also true. And we know that f of 0 exists. So both of those are out. Now we're down to A and D. Okay? Is D the answer?
No.
Or does it tell us that f of 0 exists? Okay? How do you know?
Because at a y-intercept, x has to be 0.
Correct. At a y-intercept, wherever it is, your x-coordinate is 0, right? So if you have a y-intercept, then that means that somewhere you have an f of 0. So that one's out. If you have a limit, do you have to have that point defined? No. So this is your answer, because at a limit, it could look like this. You could have a limit that exists, but there could still be a hole at that point. So that's the possibility that we're seeing here. So that doesn't guarantee that f of 0 exists. Okay, questions? Okay, so we have a free response question here. It's gonna involve more than just differentiability, but we are gonna look at all the parts of it because it's good for us to practice these free response questions in full because they are not so easy. So, at an excavation site, the amount of dirt that has been removed in cubic meters is modeled by the function f of x, defined above, where g is a differentiable function and t is measured in hours. Values of g of t at selected values of t are given in the table above. So, according to the model, f, what is the average rate of change of the amount of dirt removed over the time interval from 6 to 12? So if we want the average rate of change from 6 to 12, we just need slope, right? And we're using a table because from 6 to 12, it tells us to use g of t, which is from our table, right? We don't have an equation for it. So we would just do slope, and our points would be 6, 306, and 12, 474. So we would do 474 minus 306 over 12 minus 6, and we are going to get 168 over 6, and that'll probably, I mean, it definitely reduces, but let's just, I can't remember if this is calculator active or not. We'll see whenever we get a little further whether or not we need it, but let's say that this is not calculator, that this is not calculator active. If it is not calculator active, don't even try to reduce that. You don't have to reduce it. In fact, even if it is calculator active, it doesn't matter. You can leave it like this, right? So, you can leave it like that. Now, if it is calculator active, just for like my own curiosity, I do want to know, 168 divided by 6, it does equal 28. But you don't have to divide that, right? You can just leave it. Now, when a problem gives units, you want to include units in your answer. Sometimes there's points for those units. Sometimes there's not. It just depends. So, what are the units there for this average rate of change? The y coordinates, what were they measured in? Cubic meters. So, meters cubed. And the x coordinates, what were they measured in? Hours. So it's cubic meters per hour. So 28 cubic meters per hour is our average rate of change. Okay, here. All right, now we need to use the data to approximate f prime of 9, the instantaneous rate of change in the amount of dirt removed in cubic meters per hour at time t equals 9. Show the computations that lead to your answer. So we're at 9 hours. We're still in the section where we're using this table. How are we going to estimate the instantaneous rate of change at that point? The slope of the two closest points. So this time we're using 8, 376, and 10, 428. So I'm going to say f prime of 9, and I'm going to use my squiggly equal sign. It's going to be 428 minus 376 over 10 minus 8. And that is going to give us 52 divided by 2, and that'll be 26. And this is cubic meters per hour also, for that same reason. The top is measured in cubic meters, the bottom is measured in hours. Again, if this is not calculator active, leave it 52 over 2. In fact, this is how crazy it is. If it is not calculator active, if you left your answer as 428 minus 376 over 10 minus 8 cubic meters per hour, if that was your answer, full credit. Even though you did no arithmetic to simplify it there. So, whenever you are doing these problems, particularly on things that are being graded, that are free response, you may not want to simplify, because if you make a mistake, it's going to cause you to lose points. All right, we okay with B? All right, C is continuity from 0 to 12. It tells us, we know from 0 to 6, we just have like a cubic function. Cubic functions are always continuous, right? Do we know that G is continuous? It doesn't tell us G is continuous, but what does it tell us about G? Look particularly at this intro material here. What's it tell us about G? It's differentiable. So if G is differentiable, what's that tell us about G also? Continuous. So we're going to start by saying, since G of t is differentiable, G of t is continuous. So even though I don't know much about G of t, I do know it has to be continuous from 6 to 12. So where's the only place it might not be, f of t might not be continuous? Not between 6 and 12. At 6. It's right at 6. It's two places where this comes together, right? From 0 to 6, this is a cubic. It's continuous. So 6 is what we care about here, right? So what we're going to have to do is we got to look at the derivative from the left and from the right. No, I'm sorry. That's for part D. Not derivative from left and right. Just a limit from the left and the right. Correct? Okay. So limit from the left and the right. Limit as x approach, I'm sorry, we should use t's because it uses t's here. So t approaches 6 from the left of f of t. That's just going to be plugging 6 into this equation. 48 times 6 plus 6 squared minus 6 cubed over 12. And I don't want to say this one was calculator inactive. So 48 times 6 is going to be 288 plus 36 minus, let's see, 6 to the third is 36 times 6, which is 216. So we divide that by 12. Go once. Twelve goes into 96 8 times, so we get 18 there. So we're doing 288 plus 36 minus 18, which is really just like 288 plus 18. $306. I really didn't leave enough room to do this problem right here. Now, in this case, you don't necessarily have to, like, they'll accept this is the answer, but you're not going to know if that equals what it's supposed to equal unless you actually figure it out, right? So you do have to simplify that down to 306. What is the limit as t approaches 6 from the right of f of t? It is 306. We're just reading that off of the table, right? And so I've ran out of room here, so I'm gonna go down here to finish this. Since, oh wait, I've forgotten something. What else do I need? F of 6. F of 6, we're using g of t, so it's also 306. We've got an or equal to sign there. So since limit as t approaches 6 of f of t equals f of 6, f is continuous at x equals 6, and therefore continuous for 0 less than or equal to t less than or equal to 12. Alright, let me look at these notes that I did last time, because I'm questioning myself on this last part. I know how to find an answer, but I'm questioning myself because can we find the derivative from the right-hand side? Can we find the derivative of g of x? I don't think so, because you just have a table. Because anything else is an estimate. Like if we use our estimates from A or B, they're estimates. Did I not? I added this question in. I don't have those saved. This came from AB Classroom, I'm pretty sure. Alright. Let me back up a second here. Let me go to AB Classroom and look for this. I don't want to do it wrong. You need to know the derivative from the left and the right are the same. Oh, yes. Exactly. Do we need the table for F prime 2? No, they weren't asking us about 6. But my mind was so laser focused in on 6 because that's the point that you really care about that I was not thinking. So, F prime 2, do we need the table? No. Alright, thank you, Bo. So, since we are looking just at 2, let's use that shortcut we've been using on our, that we're just getting familiar with, alright? Because I can find a derivative without doing limit definition of a derivative now, particularly whenever I just have an equation right here. So, the equation there for f of x, or I'm sorry, for 0 less than or equal to t less than 6, f prime of x, if we just use that shortcut rule, we're going to have 48t will just be 48. We got a plus t squared, so that'll be plus 2t. And then, what do I do with t to the third over 12? I don't like that fraction. Yes. So then, if I multiply out front by my 3, I have 3/12, but 3/12 reduces to 1/4. And then we'll have t to the second power. Oh no, my sign's wrong. That should be a minus. Okay, now it's important. Oh, I've messed up. You might see something I've done wrong. It's minor, it's notation. What did I put right here? F prime of x. That really should be a t. Right there, you want to be consistent. So, it is important that you put 0 to 6 because this derivative is only going to work from 0 to 6. If it was asking for 8, it would not apply. But it asks for 2, so we're going to say f prime of 2 equals 48 plus 2 times 2 minus 1/4 of 2 squared. Now, I can't stand to do this, but on the AP exam, that can be your answer. I don't like that, but it can be your answer. If we do simplify this, because I like to see what that number actually equals, we're going to end up with 52 minus 1, so we'll get 51 f prime of 2 equals 51. But that's optional that you actually take that derivative and plug it in. You can leave it with all the 2's there. And when I say it's optional on a free response question. You need to be able to do this. You need to be able to get 51. If it's on multiple choice, they are not going to leave the answer like that. You'll have to know it's 51. So you need to be able to do that. But on free response, it's optional. Okay, questions? Okay, so your assignment that you might have time to do, maybe, is going to be on AP Classroom. And let me look at it. I think you've got one free response and just a few multiple choice. Let me look. Oh wait, wrong thing. So you've got 4 multiple choice questions, and the last one is a free response. Please write your free response question out on paper. You do not have to upload it to there. Just submit it empty, but I'll check those tomorrow whenever I come around.